I'm Anil Kumar, and now we will investigate higher order derivatives with the help of graph. I feel it is important to understand how the derivatives reflect on the graph of the function. The question here is identify the graph of displacement, velocity, and acceleration of moving object and then answer the following. When is the object moving away? Explain the above from velocity graph. When is the object slowing down? Now these three are very interesting questions, and we'll also explore how they are related. As we discussed earlier, in our polynomial functions, we can see these three graphs are of polynomials. We have a cubic function, we have a quadratic function, and a linear function. Now if you find derivative of a cubic function, you will get quadratic function, and derivative of quadratic function will be a linear function. So in polynomials, derivatives, as you find, their degree decreases by 1, right? So the idea here is that if the function f of x is equals to a times x to the power of n plus something whatever, then the derivative of the function is n times a times x to the power of n minus 1. And that's what I mean. Degree decreases by 1 of the derivative. Now second derivative, f double dash x, will be n times n minus 1 times a times x to the power of n minus 2. So it further decreases, right? Now the graphs which we have are of displacement, velocity, and acceleration. So displacement is this function. Derivative of displacement is velocity, and derivative of velocity is acceleration. So that is how these three are related. So from the polynomial functions, we could straight away say that this particular graph, which is shown in bold, which is a cubic function, looks like the graph for displacement. The second graph which we have, which looks like a parabola, we'll write this graph as velocity. And the third graph, which is a straight line, I'll write this as acceleration. So this is based on the particular reason which I have given. Now let us explore further. This is kind of easier since we could correlate from polynomials. But if we are given any three graphs in general, how do we find which one belongs to or corresponds to displacement, which is velocity, and which is acceleration? So that part is kind of tricky. Let us look into this part now. So let's look into one particular graph. Let us say we are looking into this graph. What do you find at the turning point? This is a turning point. So if I draw a tangent here, then the tangent is horizontal. Derivative will have 0 here, right? Horizontal tangent means derivative is 0. Now the graph which has 0 is the parabola. Do you see that? So this parabola is the derivative of the bold graph, since that particular horizontal tangent line corresponds to 0. Well, it should be true for the second turning point also. At the second turning point, we again see that the horizontal line is the tangent, and that dotted line for parabola has a 0. So clearly we have seen that Vt, or this particular graph, now this time since we are having a different approach, we say this graph is derivative of, if I say that is the first function, of that function, because you see the horizontal lines, they match. Also, during this part it is increasing, right? Positive slope, and the derivative is positive. Do you see that? It may be decreasing, but it is greater than 0. After this point, if I draw a tangent line, it has a negative slope. So that negative portion on the velocity graph represents this negative slope. You get the idea. Now let us explore the parabola itself. Look for the turning point in any graph. So here we have a 0 of the derivative, right? So if I draw a tangent line at this turning point, I get a 0. That means the derivative has a 0. Derivative of this becomes acceleration for us. So that is how we could also see, even if they were not polynomials, from the turning point. So turning point is the second approach to look into. It could be the only approach at times, right? So turning points is very important. Now here you can see, if I draw a tangent on this half of the parabola, it is negative, and therefore its derivative is negative, less than 0 from 0 to 2. So I hope with this it is absolutely clear that how to identify which graph belongs to which type of function, okay, and which one is derivative of what, right? So I hope that part is clear. Now let us begin to answer our questions. First one is, when is the object moving away? So part A, moving away. Now this you could answer in two different ways. One, you could say, when is displacement increasing? Do you see that? If displacement is increasing, then the object is moving away. That is one way of looking at it. Second is, when is velocity positive, greater than 0? That is also moving away, right? So if we take going away one direction, then that direction will be when velocity is positive, right? So these are two conditions which we could look into. So we identified the solid line to be displacement, and displacement is increasing from point 0 to, let us say, point A, which is t equals to 1. It is increasing and decreasing thereafter. If you consider the velocity graph, it is positive when? It is positive during this part, and after this, do you see that? I mean dotted line, and after this, do you see that? So we find that the velocity graph is positive from 0 to 1. So we say from 0 to 1, and from 3 onwards, right? So you can say 3 to infinity, right? So it is positive, increasing. You will find that the displacement is increasing, right? And then decreasing and further increasing. So both give us the same answer. Is that correct? So what we find here is that the object is moving away when time, this is the time is greater than 0 or is less than 1. That is one portion. Here we have x, or let me write t here, in seconds, okay? And let me write this as in meters, just to be, we didn't give any units. Let me add these units. So it'll be from the starting to 1 second. First second it increases, and then it increases from when t is greater than 3, right? So after 3 seconds, it is moving away. And in both the portions, velocity is positive, right? And you also see that distance is increasing. Second part is, explain the above from velocity graph. Well, that is how we explain, right? So I kind of combined first and second, but I hope it is clear to you that velocity graph can also answer the same thing. So this was part B for us. Now let's look into part C, which says, when is object slowing down? So part C is slowing down. Can you tell me when? The object is slowing down when velocity and acceleration are in opposite directions. That means there are two conditions. That is, when velocity is greater than 0 and acceleration is less than 0. That could be one condition. The other condition could be when velocity is less than 0 and acceleration is greater than 0. Then it is slowing down. It really means, let us say you're moving north. If you are moving north, your velocity is positive and acceleration is 0, means you apply brakes. So you are deaccelerating, negative. That means slowing down, applying brakes when moving north. However, if you are moving south, in that case, velocity is considered to be negative. That is negative. Do you understand? And applying brakes, negative of negative, will make it positive. So that is how we need to see it. Now, let us explore the graph and see what part of the graph is when velocity is increasing or positive and acceleration is negative. Well, acceleration is negative from here to there, and in this duration, velocity is positive here. So that is the portion when the object is slowing down, right? So this is slowing down, right? So this is one portion. The other portion is when acceleration is positive, when is velocity negative? They are in opposite directions. So velocity is negative here. So that portion is slowing down. Do you see that? So that is the other portion of slowing down. So from here we get that the slowing down occurs when t is between 0 and 1, right? And when t is greater than 2 but less than 3, correct? So if the units are given, you should incorporate the units in your example. Here I forgot to write the units, so we'll just give a pass to that. I hope with this example you understand very clearly when object moves away, when it is coming closer, how can velocity explain you that, and how velocity and acceleration can tell you when is object speeding and when it is slowing down, right? Now tell me, what are the points from here? What are the time? What is the time when the object comes back to its starting point? That could be another question. So you see this object displacement is 0 here. So at t equals to 3, the object really comes back to its starting point and then moves away again, right? So these are other questions which could be asked in this type of question. I hope it helps. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you.